Hey there, welcome to the Blues Quick Start Guide. In this series of hands-on tutorials, you'll see how easy Blues makes it to build connected IoT applications. In this video, I'm going to walk you through the third step of the Quick Start. And this is the exciting step because we're going to build an actual project. Specifically, we're going to capture temperature and humidity readings and send them to the cloud at a regular interval. Now, because this is step 3 of the guide, I'm going to assume you've completed the first 2 steps and have your hardware, or your Blues starter kit, set up and ready to go. If not, head to blues.dev/quickstart and complete those steps before continuing. Let's get started. Okay, so you're seeing my browser and I have the Blues Quick Start open. I'm going to scroll down a little bit and click into the app tutorial, as that's what this video is about. And then I'm going to scroll down just a little bit because the first step just has you verify that you are using the correct hardware. And you should have most of this already in place from the previous Quick Start steps. So you should have a note card inserted into a note carrier F and have the antennas connected to the note card. The step that might be new is you should now insert your Blues Swan into your note carrier F. It should be pretty easy to slide in. Just make sure you have the header pins aligned and pressed down. And once that's in place, you should have what you need ready to complete this guide. The next step in this tutorial is creating a new Notehub project. Technically, you can use a Notehub project that already exists if you like, but I'm going to create a new one for the purposes of this tutorial and call it Weather Monitor because this project is going to take temperature readings and because I want to start from a blank slate for showing you how all of this works. Once that finishes, you're going to want to copy this product UID, this identifier, because you're going to need it in a few minutes. And at this point, you have your hardware set up, you have your backend set up in the form of the Notehub project. So really, you are ready to write some firmware. There are some different options you have for how to write that firmware, but for the purposes of this tutorial, we're going to go with PlatformIO. So go ahead and bring up VS Code and PlatformIO, which you should have already installed in the previous Swan Quick Start step of this guide. To write firmware in PlatformIO, you must be in a project. Now, if you have a project already, feel free to use what you have, or you can create a new project for the purposes of this tutorial, which is what I'm going to do. So I'm going to click this Create New Project button, and then within Quick Access, create a new project. I'm going to call this Weather Monitor just to be consistent with what we named our Notehub project. For the board, you'll want to make sure to select the Blues Swan. For framework, you'll want to leave the default Arduino in place. And then location, you can choose a different location if you want your files to be in a separate place. I'm happy with the defaults. And once you're satisfied, go ahead and hit finish to create the project. Within your PlatformIO project, you'll want to make sure that this platformio.ini file, which is the PlatformIO configuration file, has the default Swan configuration. And if you scroll down a little bit in the tutorial down here, this is just walking you through creating that new project. You can see that default configuration here. So I'm going to go ahead and copy that and paste that in here so I have that config in place. Save that. From there, you'll want to open your main.cpp file, which is in the source folder within your project. And this currently is basically just a blank slate that you're going to use to write firmware that's going to take sensor readings and then send those sensor readings to the cloud using the note card. If this is your first time seeing C or Arduino code, don't worry, as we're going to walk you through every step of this, starting with this file. The starting code in here is basically your standard Arduino boilerplate, where there are just 2 functions essentially: setup, which runs once when your app starts up on your device, and loop, which runs continuously. For our purposes, we're going to set up the note card in the setup function and then take sensor readings in loop. We'll also delay a bit in the loop so that we're not taking sensor readings every millisecond or so. The instructions to do this are all in the app tutorial over here on blues.dev. And so at this point, what I'd recommend and what I'm going to do is taking your browser and your editor and putting the two side by side so that you could easily copy and paste from one into the other. And the first step, so we already got this configuration file. The first thing we're going to need to do is grab this include of notecard.h, which is a reference to the notecard's firmware library. That library is actually already installed for you because in this PlatformIO.ini file, it is listed as a lib dependency. And the include just makes it accessible to our code. So I'll head back to main.cpp and paste this in. The other thing you might want to do is remove some of this boilerplate that PlatformIO puts in here by default. So I don't need these extra functions. Really, all you just need is the signatures for setup and loop, and then these two includes at the top. With this done, we'll scroll down a little bit and grab a define of the serial interface. We're going to use this for logging with Arduino serial monitor, which is going to help us make sure our firmware is doing what we expect it to be doing. After that, grab this next define with the product UID, which we're going to paste underneath the existing define over here. This string needs to be set to your product UID, so you'll need to head back to Notehub. Hopefully you left that tab still open to grab this identifier from here, and then head back to your firmware and paste it in so that these two match. After that, we'll head back to the tutorial, scroll down a little bit, and copy this reference to the note card, which is an object that comes from the note card's Arduino library that you're going to initialize momentarily. The code after that in this fourth block should go in your setup function. So I'm going to grab that and paste that in. And this is going to start the serial debugging so that we are able to log information. Under that, grab these next two lines and put them in setup as well. The begin function by default is going to initialize an I2C connection to the note card. And the note carrier F actually has all the necessary wiring in place to make that connection for you. So this code is going to work without any additional configuration. Finally, grab this last bit of code and paste it at the bottom of setup. Then I'm going to fix the indentation. This code is going to perform your first request with the note card. The configuration should look familiar as this is the same hub.set request that you used back in the note card quick start. But this time you're sending that request in firmware using the note card's Arduino firmware library. These J objects and functions are conveniences that are provided by the note card's Arduino library for working with JSON objects in C code. This code does set the note card to continuous mode, which tells the note card to maintain a continuous connection to Notehub. This config is great for testing and demos because it means you're going to see your data really fast being transferred. At the end of this video, though, we'll discuss how you might want to tweak this configuration to make this project ready to run off of something like battery power. Okay, at this point, we have our setup function ready to go, and it's time to give this project a try by uploading this code to the Swan. This is going to use the same process you used in the previous quick start step where you uploaded firmware that blinked the Swan's onboard LED. You can refer back to that video for full instructions, but the short version is if you're using an ST-Link programmer, you want to make sure to have your upload protocol in your PlatformIO.ini file set to ST-Link, and then click the upload button in PlatformIO. If you're not using an ST-Link programmer, which I'm not as I'm recording this video, you'll want to ensure your upload protocol is set to DFU, and then placing your Swan into bootloader mode by pressing and holding the boot button, pressing and releasing the reset button, then releasing the boot button. Once the Swan is in bootloader mode, you can press the upload button, which is going to be this arrow, in PlatformIO. Also, make sure your Swan is plugged in through a USB connection to your laptop. Otherwise, you're going to get some error in PlatformIO that your device could not be found, which just happened to me. So I'm going to go ahead and plug this in and then hit upload again. If everything worked with the build and the upload, you should see a success message that looks like this, and your code should now be running on your Swan. And with it running, you'll next want to check out the serial monitor to see the logs and make sure everything is working correctly. To open the log, you can click this button down here that looks a little bit like a plug, which is going to open the monitor. At first, you probably won't see anything here because this setup function in our main code has already run. But a quick little trick to get that code to run again is to press the physical reset button on the Swan, which will reset the Swan, run the loop again, and you should see a log that shows the hub.set request as we see it here, as well as its return value, which an empty object basically just means that everything ran successfully. And because the hub.set ran, you should be able to return to Notehub, open up your Notehub project if you still don't have it open, refresh if you need to, and you should see your device on the list. Which is cool because it means you've just associated your device with a cloud backend project. And this is the same thing you did in the first step of the Blues Quick Start, but now you're completing these actions in firmware instead of through hard-coded commands that you ran in a web browser. And now that you've made this connection, you're ready to start working with sensor data. To do so, we built a library that's set up to gather some mock sensor data called NoteCard Pseudo Sensor Library, which if I scroll down just a little bit past these steps, you'll see down here. To install the library, you can head back to PlatformIO over here, find the libraries link, which is down here in quick access, search for NoteCard, scroll down a little bit to find the pseudo sensor library, and then click the Add to Project button and select your project, which in my case is the weather monitor, and then click Add. Under the hood, this UI is really just adding an entry to the libdeps library dependencies in your platformio.ini file. But the libraries menu gives you just a convenient little user interface for working with those libraries. To start using the library, we'll go back to our main.cpp file, and then I'm going to scroll down a little bit in the tutorial because I know that the next step is going to have an include that includes that library, kind of like we brought in the Note Arduino library up here. Next, you're also going to need a namespace for using the pseudo sensor library as well. So I'm going to grab that and paste it in as well. After that, copy this code that initializes an instance of the pseudo sensor and passes it in a reference to the note card. And finally, grab this last chunk of code and paste it in your loop. So what this logic is going to do is it is going to generate a temperature and humidity value from the pseudo sensor library and then print that out to the serial log. And then it's going to wait 15 seconds, so the delay here is in milliseconds, and then loop once again, gather a new reading, print that out, and continue to do that in perpetuity. I'm not using the ST-Link programmer, so I'm going to go ahead and once again press and hold the boot button, press reset, and then release boot. This does get easier after you do it a handful of times. This is going to, again, compile this code and then flash it over to the Swan. Once that finishes, you'll again want to upload your serial monitor. And this time you shouldn't need to refresh it because it's happening in a loop, but you might need to wait up to 15 seconds, depending on how lucky you are to see the next run of this go through. And you'll see the values that I have popping out down there. The temperature reading you see is actually coming from the note card's onboard temperature sensor. That's actually why up here we initialize the pseudo sensor with a reference to the note card itself. So this value is a real value, so it is apparently 26 degrees Celsius in my office as I record this. But the humidity value is randomly generated and really just exists so that we have a little bit more data to work with, so don't expect that to be an actual reading of your office's conditions. But if you are seeing these values, that means you have everything set up and you're now ready to start sending this data up to the cloud. So to do so, let's head back to our tutorial and scroll down a little bit because we need this block of code here that's going to execute the note card's note.add request. And I'm just going to grab this and put this after the existing code, but before delay. So I'm going to chunk it in right here. And what this does is format up a note to send to the note card that includes those temperature and humidity readings. So I'm building up a body and then grabbing those values that we declared and created up here in the top of loop. This code also sets the request sync flag to true, which is going to tell the note card to immediately synchronize this change. This is, again, another value that's nice for demos because it means we're going to see our reading right away and we don't have to run an actual hub.sync request on the note card to see that value in the backend. To see this live, I'm going to go ahead and once again save, put my Swan into bootloader mode, and upload one more time. I'll teach you one other trick. If you go into VS Code's, I think it's like their launcher menu. It's Command-Shift-P on a Mac. I think it's Control-Shift-P on Windows and Linux. You can type PlatformIO and get easy access to some of their commands. So I kind of like using that for upload. There's also a keyboard shortcut that fires off the whole thing. So if you can memorize this, if you find yourself doing these commands a whole lot, it's worth memorizing these to make your life a little bit easier. And with that out there, I can again use this trick to open the serial monitor. And we again might have to wait up to 15 seconds to see a log entry. But what we should see is the temperature and humidity getting logged to the serial monitor. And then also this note.add request, which see it just came through here, basically having those readings in the note's body. For the note.add request, the note card returns a total. And that total is the number of notes the note card has yet to synchronize. So you might see this number start to go up as notes get queued onto the note card. But once the note card has initiated a connection to Notehub, which it should do right away because we're in continuous mode and we have this sync flag set to true, you should see that number start to drop or just stay at 1, which is what is happening for me here. And once you are seeing that number go down or just staying at 1, you can again return to your Notehub project, and if you go to the events list, you should see the temperature and humidity readings that you're taking flowing through from your device now into your cloud backend. And at this point, you kind of have a fairly complete project. You could pretty easily swap the Pseudo sensor library out for any type of sensor or data that you are interested in, and use this exact setup for reading those values and sending them to the cloud at whatever interval you have in mind. There is one additional feature we want to show you in this tutorial. Now, what we're doing so far in this code is taking data that we're collecting on the device and sending it up to the cloud. But the communication between the note card and its cloud backend is bidirectional. So you can also send data from the cloud down to the device as well. And one way you can do that is using a feature of Notehub called environment variables. Environment variables are basically key value pairs that you can create in Notehub and synchronize their values across devices or even fleets of devices. Just to give you an idea of where that might be useful, there's an example right in this example code. In our loop, we hard-coded 15 seconds as an interval for how often we should take sensor readings. This value might be fine for now, but suppose we deploy this project to hundreds of devices in remote locations. It'd be nice to be able to update something like this interval without having to completely update the firmware on each device. Let's look at how we can implement this with environment variables. And to do that, I'll scroll down just to show you where these instructions are in the tutorial. And then in Notehub, we'll just go back to the main device list on the project. In Notehub, you can set environment variables on many different levels of your project. You can set variables on individual devices, you can set them on fleets of devices, or you can set them on entire Notehub projects. For this tutorial though, we're just going to set an individual environment variable on an individual device just to keep things simple. And to do that, you can go ahead and double click on your device and then head to the Environment tab over here and find this section for working with device variables. Go ahead and add a new variable. We'll call it reading interval because that's what we have in mind to replace this. And we'll set its initial value to 30 and hit apply changes. Now that you have this value set in the cloud, we need to look at how you get this value down on your devices. And to do that, we'll return to our tutorial and scroll down a little bit, because we have a new function that we're going to grab that we can start by just copying from the tutorial and pasting it in at the bottom, and then we'll pause a little bit to discuss what this is actually doing. This function is using a new note card request, env.get, env.get, which is going to get the most recent value of an environment variable from the note card. In this case, we're only interested in one of those variables and called reading interval. And the rest of this code is just going to retrieve that value and try to convert its value into an integer. And if it finds a valid value, go ahead and return that. So this just gives us a reusable function to get the most recent version of this environment variable. With that in place, grab this line of code up here that is just going to declare this function so that we can use it anywhere in this file, and we can paste it up here at the top. Next, we'll grab this block of code in step 3, and what we're going to do is replace the existing delay. So instead of just delaying by 15 seconds, instead we're going to call that new function to get the interval that we should delay for. We'll send it out to the serial monitor just for debugging purposes, and then we're going to delay that much time. So convert from seconds into the milliseconds that the delay function is expecting. And then finally, there's one additional change we're going to make. Back in this setup function, we're going to need to add this line of code here. You see this little comment that points us in the right direction. Basically, we're just going to adjust the hub.set request to pass this additional flag of sync and set it to true. We're going to talk about what this flag does in detail momentarily, but for now, just know that this is going to let us see environment variable updates really quickly, which is going to be convenient for testing this feature out. And with that, for one last time, let's go ahead and save. Put your device in bootloader mode if you're not using an ST-Link programmer, and we'll click upload. When you have that code running, again, return to your serial monitor. What you should see, at least within a minute or so, is the note card finding the environment variable you set in Notehub and immediately using that as a delay between sensor readings. And you can see right here, Notehub got this delay of 30 seconds from the cloud. It spit it out, and then it's going to wait a full 30 seconds before it takes and sends in another sensor reading. To show the real value of this, though, go ahead and head back to Notehub and update the value of your reading interval. So I'm just going to set this to 60 real quick and apply the change. And because you set your note card's sync value to true up here, the note card is going to immediately receive that environment variable updates. You see it actually just happened as I was talking down here. So you should, within about a minute or so, see your change and see it apply instantly on your device. And really, this is the real power of environment variables. It gives you this ability to remotely configure devices or even fleets of devices. And you can do that configuration in the Notehub user interface, as I was doing here, or you can do it through the Notehub API, which you can learn more about in the Using the Notehub API tutorial that's in the same guides and tutorials section of the blues.dev documentation that you're already in. Before we wrap up, there's one last thing I want to discuss, and that's how we configured the note card. The configuration we have in place currently transmits data fairly quickly, which is great for learning and for demos and for what we're doing here today, and also if you're planning on running your project on mains power. If you are planning on running off battery power, though, this level of synchronizing will also drain your battery fairly quickly. If you scroll down to the end of the tutorial, you'll see some suggestions at the bottom, and I'm going to implement them in here real quick just so you can see what that looks like. Focusing on the hub.set request first, currently we have the note card in continuous mode with the sync flag set to true. We can instead set the note card to periodic mode and set the sync flag to false. With this configuration, the note card no longer maintains a continuous connection to Notehub, and instead connects according to two other values you can provide to hub.set, inbound and outbound. Inbound determines how often the note card receives updates from Notehub. So this is going to be things like environment variables. And outbound determines how often the note card pushes changes up to Notehub. Both are set in minutes, so this is essentially saying send data out every hour and check for any data coming in every 2 hours. Finally, as one last change, you can also remove the sync flag from this note.add request, as this also causes the note card to synchronize a note as soon as you add it. And I might also want to change my reading interval to be something more realistic, like taking a reading every 30 minutes. And with that, you're really ready to run this project in more of a low power environment. And really, ultimately, what you set these values to or how you configure the note card really depends on your project and how often you want to see updates and take readings versus how much energy and how much power you want to use. If this is a concern for your project, and just for a more detailed conversation of all of this, I'd recommend checking out our guide to low power design. In this tutorial, you learned how to build a connected IoT project with Blues. You used a note card firmware library to communicate with the note card and to send sensor readings to Notehub at a regular interval. You then learned how to use environment variables to configure your project from the cloud and how to optimize your project for low power usage. And that completes step 3 of the Blues Quick Start. In the final step of this guide, you'll learn how to take the data you've been collecting and sending to Notehub and how to route that data to your own cloud service.